Hey everybody. So in today's lesson, we're jumping around a little bit because I don't like the order the textbook does it in. So we went from 8.3 last section. Today we're going to go through section 8.6. Okay. And all this is doing is we're going to look at quadratic functions, and we're going to specifically look at how to find the vertex of these. So I do want to explain something. All of these quadratic graphs, if I write them out as a function, all these quadratic functions, there's some number, x squared, plus some other number times x, plus some other number. I'm using a, b, and c. All of these functions are going to be shaped like this. Does anybody remember what this shape is called, what the graph of a quadratic is? It's called a parabola, right? Parabola. Now what's cool about parabolas is they have a few distinct properties. One is that they have a vertex. Okay? They have a vertex. And the vertex is either the highest, if the parabola is facing down, the highest point, or the lowest point if the parabola is open up. So depending on which way the parabola is looking, I can find the highest or the lowest, the maximum or the minimum value. Okay, so we're going to do that a little bit in today's lesson. So first, just looking at the function, there is an easy way to find the vertex without having to do too much work. There's a vertex formula, and we can find the x value of the vertex with just a little bit of work. You just take the numbers, so whatever's in the b spot, you take the opposite of that and divide by 2 times a. Now, how could I get the y value? How could I get the output for this function? Oh, couldn't I just take the x value and plug it in? So plug in x value. And that'll give us the y value of the vertex. So to find the vertex, I'm going to take the opposite of the b value, divide by 2a. That will give me my x coordinate, because remember the vertex is going to be a point in x, y pair, a coordinate, a point. So that would find the x coordinate. To find the y coordinate, I just plug it into the function. So let's try some examples and see how good we are at finding the vertex. So let's see. The first one I want to try is, let's look at the function f of x is equal to x squared plus 6x plus 10. Now remember, we know all the pieces, a, b, and c. So to find the vertex, we'll start with the x value. X value. So the x value of this vertex is going to be the opposite of b, which is 6, so it's a positive 6, so negative 6 divided by 2 times a. Well, what's the a value here? It's just 1. So let's see, that's just negative 6 divided by 2, so negative 3. So we got half of the vertex, because the vertex is going to be a point. How can I find the y value? Just plug it in. Plug in our negative 3. So remember, I strongly suggest that when you go to plug in things, you rewrite the function with a blank set of parentheses everywhere you see an x, and then you put that value in there. Strongly suggest you use the parentheses so you don't mess up things like negative 3 squared. Negative 3 squared. So you can just type this on a calculator now with these parentheses exactly like you see it, because we will allow calculators, or we could do it probably pretty easily in our head. Let's see. Negative 3 squared is positive 9. 6 times negative 3 is negative 18 plus 10. So if I add these things, 9 plus negative 18 is negative 9. Negative 9 plus 10 is positive 1. So there's the other half. So the coordinate that I get for the vertex is the point negative 3, 1. So there. Awesome. Any questions on finding the vertex? Let's do one more vertex example, and then let's go on to talking about finding a few other important points on these quadratic functions. So find the vertex for, let's go with, well, call it a function, f of x equals x squared minus 4x minus 12. So remember, we can find the x value first, and that's just going to be the opposite of b. And notice that b is negative 4, so the opposite of b here would be positive 4 divided by 2 times, and the a value here is 1, so that's just 4 divided by 2. So that's really simple. 4 divided by 2 is 2, so there's the x value. How can I find the y value? You have to understand this relationship with functions. If I have the x value, I only need to plug in to find the y value. So please connect those things. So I'm plugging in a 2. So once again, you could just use a calculator here, but we can probably handle this in our heads. 2 squared is 4 minus 4 times 2 is 8 minus 12. Okay, let's see. 4 minus 8 is negative 4. And negative 4 minus 12 is negative 16. So there's my y value. So what's the vertex here? The vertex is 2, negative 16. Because it's always just a coordinate, a point. So awesome. Hopefully you don't feel too intimidated by that. It's pretty simple. So now the other thing we want to talk about, so there's special points, or is a vertex on those graphs, but there's other special points. If you look at these graphs, they're going to have a few other special points. If I draw the xy coordinates, these graphs are going to possibly cross the x coordinate and the x axis and the y axis, so they'll have these things called intercepts. So I'd like to be able to find the x and y intercepts. But that's not too hard. To find the y-intercept, so make sure you write this down. The y-intercept, that's when x equals 0. It's always when the opposite letter equals 0. So if I know the x value, I can find the y value. Just plug in 0. That relationship between functions makes this one easy to find. Now to find the x-intercept, that's going to be a little bit more work. That's when the y equals 0. So what are we going to need to do? We're going to need to set the function equal to 0 and solve. Thankfully, we've spent the last few sections working on solving. I can factor or use the quadratic formula or use the square root property or whatever I need to solve. So to find intercepts, the y-intercept's the easy one. You just plug in 0. The x-intercept takes a little bit more labor. So let's run through a few examples here to find the intercepts. So if I want to find the intercepts of f of x equals x squared plus 6x plus 10. Now, if you've noticed, this is the same example we did earlier where we found the vertex. What was the vertex? It's the first example we did. I believe the vertex was negative 3, 1. Okay, so now we would like to find the intercepts. So let's find the y-intercept. So remember, to do that, we're just going to plug in 0. F of 0. So the y-intercept happens when x is 0. And it's really easy, if you know the x value, to find the y value of a function. You just substitute in or plug in that x value. So this should not take a calculator, because what's 0 squared? 0. What's 6 times 0? 0. I wrote a 6. I'm crazy. 0 plus 0 plus 10. And hopefully everybody sees that that is 10. So to find the y-intercept, can I write it as a point? As a coordinate? Well, yeah, I know the xy pair. What x value did you plug in? Oh, it was 0. You said that's when the x value is 0. What's the y value that comes out? 10. So that's the y-intercept. 0, 10. So now, can we find the x-intercept? That's the one that takes a little bit more labor, a little bit more work. That's when we want to set it equal to 0 and solve it. Let's see, was that nice? You can use the quadratic equation if you want to, but it might be worth looking to see if it factors. Does it factor? Let's see, 2 times 5, no. 1 times 10 doesn't add to that. No, so we might need to use the quadratic equation. Not too hard. X equals opposite of b, so negative 6, plus or minus the square root of 6 squared minus 4 times 1 times 10. I'm going really quickly here because we've already spent a whole lesson on the quadratic equation. So hopefully you feel confident in plugging in and doing these steps. Let's see. 2 times 1 is 2. Let's see. Can I do this part in my... Well, maybe I could write it out. 6 squared is 36, right? Minus 4 times 1 times 10 is 40, isn't it? Make sure I didn't make any mistakes. Yeah, that's 40. So what do I get? Negative 6 plus or minus the square root of negative 4. So quick review from last lesson. I have a negative discriminant. That means I'm going to get complex numbers as my answers, 2 complexes. That's not too bad. I can handle that. Negative 6 plus or minus. Let's see. What's the square root of 4? That is 2. And because it's negative, it's going to be an I, a irrational number. And then does 2 divide evenly into both of these? Yes, it does. Negative, let's see, what's 6 divided by 2? Negative 3 plus or minus 2 divided by 2 is just 1, so that just leaves us with an I. So do I have 2 x-intercepts yet? I do. They're not real numbers, though, so they're not actually on the x-axis. Not going to be on the grid here. So these are not going to appear. Does anybody know how that would look on the graph? So those are complex numbers. Our xy axis, those are real numbers. What that means is that this one is going to be at negative 3 1's the vertex, and it's open like this. It never actually crosses the x-axis in our real number plane. So there's no real x-intercepts. There are imaginary ones, complex ones, but no real ones. Okay. Let's do one more example of finding the intercepts. So the same example that we found the vertex, the second vertex on. So the function is x squared minus 4x minus 12. So it'll be really easy. We've already found the vertex to find the y-intercept, because all I have to do is plug in a 0. So let me do that. Plugging in the same way I always do. Leave blank parentheses and then go back and write in your x value. And we should be able to do this in our heads. 0 squared is 0. 4 times 0 is 0. Minus 12. So the y-intercept, it crosses at negative 12. What's that point? Well, 0. Negative 12. That's the x value that we plugged in and the y value that came out. So there's the y-intercept. Can we find the x-intercept? And hopefully this one will be real this time instead of complex. So we're going to want to set our quadratic equation equal to 0 and try to solve it. Does this one factor? Actually, I believe this one might actually factor. Let's see. If I do x minus 6 and x plus 2, does that give you back this? Let's see, negative 6 times positive 2 is negative 12. Negative 6 plus 2 is negative 4. So yeah, this one's actually pretty easy to find these intercepts this time. I have 2 real number intercepts. So let's see. I add the 6 over, so x equals 6. Subtract the 2 over, so x equals negative 2. So I have 2 x-intercepts, and they are going to be, the x value of 1 is 6. What's the y value again? That's what we set it equal to. Remember, the other number is always 0. 6, 0. What's the other one? The x value is negative 2. What's the y value? 0. Now, why is it cool to know these things? Well, I know where the vertex is. I know where the intercepts are. That's kind of the beginnings of being able to graph it, right? So we could find the vertex, and we could find that it crosses at a point 0, -12, and it crosses at -2, 0, and 6, 0, and you kind of start to see what the graph will look like from knowing these points, the vertex and the y-intercept and the x-intercepts. And these are also very important points to know when you're asking concept questions. And that's where we're going to go next. Okay? Where we're going to go next is using our ability to find the vertex to answer a word problem. And the word problem is not really that hardcore. It's actually quite interesting. I'm able to find the minimum or the maximum of something if it is a quadratic. Notice this is x squared, x number, so this is a quadratic. So I can find the maximum or minimum just by finding the vertex. So look at this one. It says the cost, C, in dollars, of making bicycles, x number of bicycles, is given by this function. Find the number of bicycles that must be made to minimize the cost. And let's find the minimum cost. So that's an interesting question. Because one of these, I bet, are the x value of the vertex, and one of these are the y value of the vertex. That's actually how it's going to work out. So let's see. Let's write the function over again so we have it on this page. 2x squared minus 800x plus 92,000. So we'd like to find the minimum cost, and we'd like to find the number of bicycles to get that minimum cost. Well, let's think about this for a second. Cost is what's coming out. So cost would be the y value, right? Cost. That's the y value. Now what's in there is x, and if you go back and read the problem, it said the number of bicycles. So the number of bikes, that's what's being put in there. That's the input. That's the x value. So they ask us for the minimum. So that means I'm looking for the vertex of this quadratic, and they're just asking me, part A is asking you for the number of bikes. Part B is asking you for the cost. So they're just asking for the x and the y value of this vertex. You'll have a question just like this on the test, and it's actually really easy to solve. Remember, how do I find a vertex? I have that very simple formula to find the x value, then the y value. So to find the x value, remember it's the opposite of b, so positive 800, divided by 2 times a. So this is going to be 800 divided by 4. 800 divided by 4, that's 200. Now, x is bicycles. So to answer part A, how many bicycles do I need to make to minimize the cost? I need to make 200 bicycles. I'm just going to put bikes because bicycles is a lot longer to write and spell. All right, now how can I find the actual cost when I've minimized the cost of making these? Oh, I just need to plug this back in, right? So to find the actual cost, I need to take my function and plug back in this x value that I found. Whoops, not an x that time. Now we may want to use a calculator. Maybe you're really good and can do it in your head, or would like to write it down. Let's see, what am I plugging in? 200. I'm going to use a calculator, and I'm going to put this in exactly as I see it with parentheses. I'll go, let's see, 2 parentheses 200 close parentheses squared minus 800 parentheses 200 close parentheses plus 92,000, 1, 2, 3 zeros. And my calculator tells me that the minimum cost to make this many bicycles is 12,000. So awesome. Now what's the units going to be on that? So make sure we do include units. So minimum cost, well, cost is money, right? Minimum cost will be $12,000. And so to find a minimum or a maximum, depending on which way the vertex will be, which way the parabola is facing, all you do is find the vertex. The x and the y coordinate will answer the two questions. That's all we have today. Make sure you try your worksheet and email me any questions you have.